video is going to pick up with piecewise functions, and in this one we are actually finding the equation that matches with the piecewise function that's shown. So I have a series of steps here, and I'm going to scroll so we can see a lot of these. These steps are what you should basically be thinking about in your head whenever you're coming up with the equation of a piecewise function. So step one, you want to see how many pieces you have. In this problem, we have 3 separate pieces, so that means I'm going to have 3 lines in my piecewise function. Step 2, determine the domain of each segment. So you want to look at your left and your right values for each of the pieces that are shown. Now in the ones that are here, you see everything is a line segment, so you're going to have an x that is confined between 2 x values. In a lot of the other types of questions we're going to be working on with this, your domain is not going to be limited to being bound between 2 x values. In many cases, it'll actually be open on one side. So if, instead of a dot here, like for this blue segment A, if there was an arrow going on to the left, you would have x is less than some number instead of x is in between the 2 numbers of the domain. So just keep that in mind. I think you'll see that tomorrow whenever I share the video for the worksheet for piecewise functions. Step 3, for each segment, you're going to use the graph to locate points on the line and find the slope. The points on the line, typically we want to find the y-intercept, because that will allow us to use in step 4, y equals mx plus b, or f of x equals mx plus b, to come up with the equation for the function. I am going to limit these types of questions to linear pieces. I am not going to make you come up with the equation of a quadratic piece, but that is something you should keep in mind while you're working. So let's give us just a little bit more space here. The video does block out some of this. Okay. So we have 3 separate linear pieces, and I'm going to use the appropriate colors for each of these whenever I'm going through. So I have f of x equals, piece A is in blue, so I'm going to be using blue anytime I write about it, just to help keep things consistent. Notice each block is counting by 2s, so it looks like I'm starting at this block here that has an x value of -2, and I'm ending here with an x value of -1. So my domain is that x has to be in between 1, I might have said -1, I meant +1 here, because this is a positive 1x at that spot. X is in between 1 and -2. Always put the lowest number first because you're using less than signs. The -2 was a closed dot, so I would put a line underneath that inequality. There's no line under the inequality with the 1 because that was an open dot. The next piece is B. Piece B starts at an x value of 1 and ends at an x value of 5. And both of those are closed dots. So they are both going to have lines underneath the inequality. A bit more space here for the last one. For green, that's piece C. It starts at 5, and it's going to end at 8. 8 is a closed dot. 5 is not a closed dot in this instance. You actually have an open dot underneath a closed dot, or a closed dot at the top of an open dot. So because we determined that the 5 in the red was closed, the 5 in the green has to be open. You cannot have 2 closed dots that are existing in the same spot, otherwise it would not be a function. So we have to make a determination there of which one is closed, and we decided that the 5 was. So now we're going back to the blue line. We want to look at some points that are on the line in order to come up with some type of equation. So I can see I have this -4 on the line, and that is actually going to be the b value for this blue piece. The slope of this blue piece, if I go from point to point here, I would be rising 3 blocks and running 1 block, and each block is going to represent 2. So So you can think of this as 6/2 or 3/1. In either case, my slope is going to be 3 for the blue APs. So step 3 and 4, I'm going to kind of combine together to come up with the equation here. So slope is 3, y-intercept is 4. The blue piece equation is going to be 3x minus 4. The red piece, also diagonal. So the red piece is also diagonal. The red piece does not have a y-intercept, but I could count backwards to figure out where that y-intercept would be. So even if you have a diagonal segment that does not cross the y-axis, you can figure out where it would cross the y-axis if 0 was included in the domain of x. The slope of this red line, if I do my rise and my run, I would rise 4 and run 4. The slope is 1, so I'm going to have a 1x. The y-intercept, if I count backwards, would actually put me at 3. So the equation for the red piece is going to be 1x, or just an x, plus 3. And then lastly, I have the green piece. The green pieces that look like this, or not all green pieces, but this particular piece is horizontal. Since it is horizontal, that means that the slope is 0. So if you have a line that has a slope of 0, those are the equations where y equals a number. That number is whatever height you're at. Again, we could follow this backwards to find the y-intercept, but that's also going to be the height. So the b value for the green is going to be 8. You could write 0x plus 8, or you could simply write 8, because 8 is the height that it occurs at. All horizontal pieces we write as an equation just with whatever their height is. And then this would be your solution for your problem. All 3 pieces are defined, all 3 domains are defined, and then you have your equations. We're going to skip this one, not something I want to focus on at this time. I do want to go on to this one though. This is an example, a real-world example of where you might see a piecewise function. This is a company that changes their shipping costs depending on how much the shipment weighs. And you can see there's different ranges here, or different categories. So we have 0 to 2 pounds, where 2 pounds is included, and a shipping cost of $5. 2 pounds to 4 pounds, 4 pounds included, 2 pounds would not, because again, 2 would fall into this lower bracket, although 2 is the beginning of the middle bracket. But 2 to 4 pounds would be $8. 4 to 6 pounds, 6 included or not, because again, 4 would be in that lower cost, that would be $11. And then 6 to 8 pounds would be $14, 8 included, 6 again in the previous bracket. We are going to graph this, and then we're going to talk about the domain and range and the maximum and minimum intervals, or maximum and minimum values. So again, I'm going to expand this just a little bit so that my video is not as much in the way. So let's use some black here to label this. And we do have enough that we can actually count by ones, although I'm only going to label every other box. So there would be 2, 4, there's my 6, and there's my 8. And this would be weight. And then I have 2, 4, 6, 8, 10, 12, and I have to add one more line to get to my 14, and this is going to be shipping cost. So from 0 to 2 pounds, we're going to be paying $5. However, if something weighs exactly 0 pounds, you're not paying $5 because there's no line underneath the inequality. So from 0 to 2, I'm going to be at a height of 5. At 0 is going to be an open dot, though, because, again, there's no line under the inequality. And that's going to go the whole way over until an x equals 2. So now I have my next region. From 2 to 4, it's going to be $8. But at 2, again, that's my open dot because I'm not actually going to be paying $8 at 2. But the very next weight above 2, I would be paying $8. So I have to represent that I'm starting at 2, and we can do that with an open dot. And that's going to go the whole way until a shipping weight of 4 pounds. Next, 4 to 6, I'm going to be at a height of 11. Again, this is going to be open dot to closed dot. And then 6 to 8, I'm going to be at a height of 14. Again, open dot to closed dot. And this is what a function would look like if you were changing, if you had a consistent value between certain x values. If we were looking at this in function format instead of a table, it would look like this. If f of x was my shipping cost, it would be 5 if x is between 0 and 2, including 2, 8 if x is between 2 and 4, including 4, 11 if x is in between 4 and 6, including 6, and then 14 if x is in between 6 and 8, including 8. So this would be the traditional way you would see that instead of in a table. I just wanted to add that so that you could see how it would relate to what we've done before. So now we have domain. Domain, again, represents the x values. So all weights between 0 and 8 are accounted for. However, 0 is not included. So 0 would get a parenthesis, 8 would get a bracket. The range would be the different y values that you have. Now, the lowest shipping cost that we have is 5, and the highest is 14. But I can't write the range like this. Because if I write the range saying 5 to 14, that means every number between 5 and 14 would be included. And that's not what's going on here. Based on this chart, we are never going to pay a shipping cost of $6. We're never going to pay a shipping cost of $7, of $9, of $10. So instead of writing our range out like this, since it is a series of values, we would actually go through and list the numbers. So my range is 5, 8, 11, and 14, because there are no other y values we are going to reach within my graph. The minimum value is going to be the lowest y value. The lowest y value on this graph is 5. The maximum value is going to be the highest y. The highest y that we go up to is 14. Minimum and maximum, we're going to talk more about that in the coming sections, probably more so in topic 2. So if that doesn't quite make sense yet, that's okay. What we just graphed is called a step function because it pairs every input within an interval with the same output. It actually looks like floating stair steps whenever you look at the graph. So step function looks like you could just walk right up those steps on your graph. That's going to be it for this section. Wasn't sure if I had anything else after that, so I apologize for adding in that extra slide. I hope this was useful. Please go back and review this for any of the questions that you need to do. And contact me, send me a message in Schoology or an email if you do have any additional questions.